welcome to the Satellite Image Deep Learning Podcast. I'm Robin Cole, and it's my pleasure to present another technically focused episode in the series. In this episode, I caught up with Daniele Rege Cambrin to learn about earthquake epicenter detection with Sentinel-1 images. Daniele has a key role in organising a new competition on this task. We had a great discussion about the logistics of this competition and the lessons he learned from organising a previous one. I hope you enjoyed this episode. Hi Daniele, welcome to the podcast. How are you?
Thanks for the invitation, and I'm glad to be here with you. And really thanks.
Fantastic. Now, I know you from your involvement in the ChadBud challenge. Do you mind telling us a bit about that challenge?
Okay, so the last year we ran a machine learning competition in ECML Ph.D. And it was a great experience from my point of view. It was quite interesting for us, learning how to run competitions, to deal with people, deal with technical issues, etc. It was mainly about some topics on remote sensing. In particular, we focused on a problem that was quite, explored. That was burned area detection mainly. In this case, we want to address the delineation problem, so segmenting the areas. And so we collected, I think, a reasonable number of people, 20, 30 people, more or less. So we have to deal with a reasonable number of people, not too much large people,
Right.
but it's quite challenging from a first experience point of view, I will say. And now I hope to go for another run about
Fantastic.
another competition.
Yeah, so that challenge was segmenting fire burned areas. So just curious, how did it work? Like, how did people innovate their solutions? Did they take the baseline and make iterations, or did you see completely different solutions emerge?
So from what I've seen, mainly people have not changed it too much the baseline. They tried different solutions that are completely different from what we proposed. Some people try to stuck with classical indexes, for example, or other classical machine learning algorithms. It seems to me these indexes and classical solutions do not provide any good results, at least from what I've seen from the leaderboard, I would say. And the other people focused on, for example, more UNet-like architecture, I would say, and their variation, and also they try to work with the different spectral bands of the images. For example, one of the winners focused only on the false composite color, for example, without using all the available channels in the images.
This is Sentinel-2 channels, was it?
It was 12 channels because we used the images from Sentinel-2. So we have both RGB and infrared, and also an ultra blue channel, if I remember well. But people try to improve and use other solutions from UNet-like. Our baseline was a simple DeepLab v3, if you know the model. And they do pretty good, I will say, since they beat the baseline on 20 points, I will say. So
so successful outcome for yourself as organizers of the competition. Good quality solutions on that task.
Yeah, I will say they work at least. So this is important for sure. If we are doing some applicative, I will say some application of current machine learning. So they work at least. They propose some good solution without, for example, as I said, using every data disposal, every channel disposal. So they innovate, I will say, using only a part of the data. This is good, since this means that you don't really need everything that available from our point of view. And yes, as I said, I was quite satisfied from the results, since they beat our results, I would say. So this is a good point.
And was there a particular metric that they were judged on?
So they tried to maximize the classical intersection over union, I would say. This is a binary problem. So it was quite good to evaluate the intersection over union
Right.
levels. And yeah, as I said, I've not seen any big ensemble, more or less. So this was
Mm.
also a point. We tried to force people using small model as possible to improve existing models, use existing models without simply saying we assemble 10 models and yeah, for
Yeah.
sure, assembling more models is good than using single one. But we forced adding a constraint to not use more than one GPU. That was, I would say, it's arbitrary, I would say, since a GPU can have 80 gigabyte or 40 or 12 or, but was simply a manner to avoid people
Right.
using, as I said, large ensembles.
Right. So I think the challenge there is, individuals might not have the same resources as a team at a large, organization. So you're trying to level the playing field a bit there, and I guess get a bit more engagement as a result.
Yes, as you said, people have to be, I mean, they must have the same instrumentation, the same abilities to, it's a game, more or less. So every people have to be in the same setting of other people to play right and fair with other.
Hmm.
Everyone have the possibility to win. I'm quite passionate in game, and I know
Right.
this.
That's fantastic. And so you've moved on to another competition this year. Do you mind telling us what that one is about?
Yeah, as you mentioned, we want to run another competition on a different topic that I think is more underexplored, is linked to earthquakes this year. So we want to focus on their detection, in particular to the detection of the epicenter, mainly since from what I've learned from literature and other people working in geophysics, etc., currently is quite time consuming from what I've learned. You need more stations, and each station have to detect the waves, and then to detect the epicenter, you have to combine all the detection of the different stations to understand where is the epicenter.
Right.
So seems more time consuming, while in this case, simply having an image and then say the epicenter is here, is not here,
Right.
a solution also
So
to,
hopefully we can come up with a solution that just takes satellite images rather than doing all this triangulation with ground sensors, right?
yeah, we have also seen people working with this type of images from Sentinel-1 to detect the area affected by earthquakes manually, I will say. So
Hmm.
seems feasible using the SAR instrument for this type of challenges, I will say. So understanding earthquakes.
Right.
And this is why now we have to propose a baseline. I've already tried something and it should work. I hope people will try to propose a better solution for sure,
Hmm.
since, as I said, they could be useful to the humanity, I would say in this case, but also to geophysics, etc., etc. So
Right. So the gauntlet is thrown down, a more challenging task potentially, and a different sensor this time, Sentinel-1 being the SAR sensor, of course. And what kind of data do you provide? Is it a single image? Is it a time series?
okay, as done in the previous year, we focused on two bitemporal time series, I would say. So two images, if you prefer calling them in this way. And this is done because from our experimentation, but also from other people experimentation in manual, I would say, detection of these hazards. You need two images because you need the interferogram, if I'm calling it well.
Right.
Probably you are better than me in this. And so, yes, also in this case, we want to people focusing on change detection, I will say,
Yeah.
but oriented in this way, detecting
So
the.
yeah, just to summarize there, you obviously have a before and after SAR image. The ground has moved. You can do this, generate an interferogram, as you say, which will tell you how the ground has changed. So presumably people will be using single image with interferogram. And then the actual annotated data, you said it's the center of the epicenter of the earthquake. So is it a point? Is it a segmentation mask?
It's a point, as you said, since the epicenter is 1 point.
Right.
Our, trustable source, I would say, that is the International Seismological Center. So we can trust them, I hope. And from their data, we try to map all the epicenters on images, I will say. So yes, as I said, you have to regress a single point, but I think it's not really straightforward, as you said before. Seems more complex than simply segmenting, for example,
Yeah.
area, since you can rely on visual features, while SAR, as you mentioned, is not really a picture, an image, is more radiometric, if I'm calling this type of image as well, I would
Yeah.
say.
Well, it sounds like a really interesting task. I'm really looking forward to seeing the solutions people come up with. And as you say, something a bit more, I think, involved than just segmentation. Um, Obviously, this is your second competition. I'm curious, what's it like organizing these competitions, running them? Did you learn anything significant in the first one that you're going to change the way you run the second one?
So from our point of view, I think we will change the platform. So this is not really linked to our previous competition, I will say, but it's a change from our point of view. We have to learn to deal with another type of management. Also, as I said, from our previous competition, from what I've seen, at least, there is I would say there is not you are not busy for all the time of the competition. You have really low effort times, and other times you have to deal with many things, since at the beginning you have to release something, then you have to give people time to deal with your data, then you have to release the test, you have to deal with the final part in collecting all the results, understand their reports, for example, try to, there are many things that I will take in account, at least in dealing with 30 people, as I said, 20 people. Probably if you have 100 people, it's not the same. I've also taken part in some other competitions, so I'm pretty sure that larger competition are more complex. But as I said, since our goal is not simply dedicate all our time into this competition, but letting people try solving interesting problems, probably. We have to manage our time in dealing with solution and other things. So this is, I think, if you want to run a competition, you must have in mind this type of thing. So there are moments in which you are involved more in the competition, in dealing with things. Other times in which you have to do nothing. So this is a point that you have to take into account. Other problem as releasing the things, that is not so straightforward, because also speaking to another guy, he told me the size of the things have to be comfortable for people, because as you said, probably are common people, not big societies, big companies. So they have to deal easily with your data, with models. They have to be fair, the competition, as you said. So it's not so straightforward. We have to think well, which are the constraints you want to pose, if they are feasible, if you could evaluate the results well. So there are many points that I've heard from.
Okay, so a few lessons learned around the organization and scheduling, I suppose. Change of platform. Which platform are you going to be hosting this competition on then?
So probably we will go for Codalab, that is quite well renowned, I think, this year, since, as I said, the point is simply progressing a point. So it will be more straightforward for people sending their, I would say, their predictions, and it is easier for us evaluating the results. So I would say we will go for Codalab. This is free, available for this type of challenges. It is working.
And do they submit code? Do they submit model weights? Do they somehow, you know, generate some predictions that you evaluate?
So for sure, they have to submit the predictions. Also this year, we would like to, also the previous year, we suggested people opening their code for evaluation. We have not run their code.
Yeah.
This year, instead, we would like to understand better the resource consumption of their models. Since we want to prove that I will say bigger is not better, I will say. So also from my experimentation, from my understanding, empirical understanding, I will say these tasks are not so complex. And so you don't really need to involve, for example, I will say a SEM-like or something similar. Using a mobile net, you got good results. So forcing people in using low resource models will be a constraint to force people simply not saying, I will go for bigger models, as I said, and I think everyone could take part with a small GPU,
Yeah.
for example, or a simple GPU if
Yeah.
take with classical things.
Okay. Just one question. If they're providing the predictions, that mean they have access to the test data set. How do you prevent people overfitting on the data set?
So in the first part, we will provide, as done in the previous year, only a public validation, I will say. Also, in this case, we will provide the ground truth, I will say, also for the public. But since it's more like a self-evaluation, I will say, and to let know if you want other people how you are performing, it's like a way to force people in saying I'm doing better than you. So keep the challenge running
Yeah.
and doing better. This is simply the rationale, I would say, around the decision. And from my point of view, I think it can work. And also from the previous year, I've seen that people are submitting, try to doing better. Some people have overfitted, but at a certain point, it could be clear, since if you go up 90%, I would say it can be suspicious.
Right.
And instead, for the real private test set, we are simply releasing the data without the prediction, as done in the previous year, so people cannot overfit in any
Okay.
case.
Fantastic. Okay. Well, thank you for the overview and the history of the series. Why don't you tell us the basics? When the competition begins? When does it end?
So for now, we have to deal with the proposal, since we are waiting. It should be in these weeks, I will say. The call for the proposals, and then if the timeline is the same of the previous year, from March, April until the end of the summer, I will say.
Okay. So yeah, spring in 2024, ending in summer.
Yeah, according to the previous year, as I said, I don't know this year, but I hope they will come soon. They will come to us soon with the deadlines for decisions.
Fantastic. Okay, well, I'll include the details for the competition in the show notes. People can check them out there. If people want to follow you personally, Daniele, what's the best platform?
Following me, you said,
Yeah.
you can follow me probably, yeah, searching for me on the internet. It's my name and surname, Daniele Rege Cambrin. It's unique. I'm the only one with this name, so you can find me easily, I will say. You can reach me by email. You can find me on Discord or other social, LinkedIn, for example. You can follow me. Or what do you prefer? As I said, I'm also a game passionate, so you can find me on a game platform, I would say.
Oh, okay.
If people are quite passionate and want to play.
Yeah. That's another invite then. 2 competitions are running.
Yeah, for sure.
Yeah,
As I said,
awesome.
I'm really passionate. This is why I'm running this competition. It's like a game. I like games.
That's great.
Like.
Wonderful. Well, once again, thanks again, and looking forward to the competition.
Okay, thanks. I hope to see many people this year as in the previous year. And thanks to you, Robin, for the invitation and to discuss with you about these topics and new things, I would say, in machine learning field.
It's my pleasure. Okay, ciao.
Ciao.